Today we're going to talk about how to find attributes from both standard form and vertex form of quadratic equations. So we're going to be finding the same attributes, but based on how your equation is written, you might have to use different formulas to find, let's say, the vertex in standard form as opposed to vertex form. So you'll notice here in the first two boxes, you've got the standard form of a quadratic, so y equals ax squared plus bx plus c. And then you've got vertex form, so y equals a times x minus h squared plus k. So that's actually what we're going to look at typically to find our transformations, because you have your h and your k, which are going to be exactly like your c and your d in the absolute value function that we just got done studying. So in standard form, in order to find the vertex, you're going to use the formula negative b over 2a, comma, f of negative b over 2a. And remember, when we have f of something, that just means you're plugging in that value for the x, okay? Because our vertex is an ordered pair, so it's in the format x comma y. So in order to get your y value, you plug in the x, okay? So for this example, number one, our a is 1, b is 8, c is 7. So just like when we were completing the square to change from standard form to vertex form, your a, b, and c values are going to be represented by your coefficients. And for this particular piece, we need it in actual standard form. So we don't want our constant on the right side. Okay, so your vertex, I want to do negative b over 2a. So negative 8 over 2 times 1, which is going to be negative 4. So that's the x value of my vertex. And then I want to do f of negative 4. So f of this negative b over 2a to find my y value of the vertex. Okay, and so we're plugging that in up here to the original equation. So we have negative 4 squared plus 8 times negative 4 plus 7. So that's going to be 16 minus 32 plus 7, which equals negative 9. So my y value of the vertex is negative 9. So negative 4, negative 9 is my vertex. Okay. Your maximum and minimum are going to be determined by your a coefficient. So just like when we did transformations, your a value still represents your vertical stretch and compression and your reflection. And then it also represents your reflect across x-axis. Whoops. So if you have a minimum, which looks like this, that's going to be a positive a value, just like with their absolute value. If it points up like that, you have a positive a value and a minimum. For a maximum looking like this, you would have a negative a value. So this particular example, example number one, has a minimum at the vertex negative 4, negative 9. Okay, your axis of symmetry always goes through the x value of your vertex. So your axis of symmetry is a line. It's a line called x equals, because in a parabola, your axis of symmetry is a vertical line. So x equals, and your value is going to be negative b over 2a, which I just said is the x value of your vertex. So you don't have to do that calculation again. So we know that our axis of symmetry here is x equals negative 4, x value of your vertex. And then your y-intercept is really easy to get from vertex form. Your y-intercept is going to be the point 0, comma c. So over here we've got 0, comma 7. If we wanted to do this next example, it's already in standard form. So I've got a equals negative 3, b equals 18, c equals negative 39. So then our vertex is going to be at negative b negative 18 over 2 times a, 2 times negative 3. So we have negative 18 over negative 6, or 3. So my x-coordinate is at, 3. And then my y value, I'm going to plug in a 3 up here, 3 in for x. So I have negative 3 times 3 squared plus 18 times 3 minus 39. So we could type that into Desmos if we wanted to. So 3, negative 12 is my vertex. Okay, this one I have a negative a value, so it's going to have a maximum. It's going to be reflected downward. My axis of symmetry is going to be through x equals 3 because it's going to be the x value of my vertex. And then my y-intercept is my c value. So 0, comma, negative 39 would be my y-intercept. Okay, vertex form, like I said, is very much like when we did transformations as far as your c and your d values go. Your h is a c, your k is a d. So you could write it like this. Let me scoot this where you can see it. Okay, so vertex form instead of h and k can also be written as a c and a d. And then that's going to do exactly what your absolute value did as far as transformations go. So your vertex is going to be at the point h, comma, k, or like when we did our absolute value c, comma, d. Same thing. It's always going to be the opposite of what it appears because of that minus sign. So if it says x minus 2, your x value, or your x value of your vertex is actually just going to be a positive 2. Okay, minimum is going to be the same as before, positive a, maximum negative a. Your axis of symmetry is x equals h, or x equals c, just like absolute value. It's going to go through the x value of your vertex. Okay, your y-intercept, we're going to have to do a little bit more work in vertex form. Your y-intercept is at the point 0, comma, f of 0, meaning we're going to plug in 0 for x and see what we get for the y value of that coordinate. Okay, so if I were to want to do my attributes from vertex form, this says we want to take the above example, x squared plus 8x plus 7, and we want to convert that to vertex form. So we're going to have to complete the square. So I'm just going to use some space up here. Okay, remember we're going to move the 7 to the other side. So I have x squared plus 8x plus blank equals negative 7 plus blank. And then we're going to fill in the blanks with half of b squared. So 4 squared, which is 16. So I'm going to put a 16 and a 16. Okay, we write this side as factored. So x plus 4 squared equals negative 7 plus 16 is 9. And then I'm going to move the 9 back over. So vertex form would be y equals x plus 4 squared minus 9. Okay, so that's going to go right here. X plus 4 squared minus 9. So remember in this equation, we have x minus h squared plus k. So my a value here is a 1 because it would be anything imaginary out here. Your h value is negative 4 because remember, just like when we did absolute value, it's the opposite of what's inside there with the x. And then my k value is negative 9. So my vertex would be at negative 4, comma, negative 9, which is exactly what we got up here in standard form. Okay, same exact attributes because it's the same exact parabola. Okay, this one is still going to have a minimum because we have a positive a value and it opens up. My axis of symmetry is x equals negative 4. X equals my h value. And then my y-intercept we said is going to be at the point 0, comma, f of 0. So I'm going to plug in a 0 up here for x, I have 0 plus 4 squared minus 9. So 16 minus 9, which is 7. My y-intercept is at 0, comma 7, which is true from the top one. Now, this one I have transformations listed. Okay, your transformations, you'll refer back to your absolute value notes to remember what each value does. But your A value in summary is still your vertical stretch or compression, and your vertical reflection. Your C value is still your shift left, right. And then your D value is still your shift up or down. Okay, so this one I have an A value of 1. It's not going to change anything. It's not going to transform it. Your C value or your H value, same thing here, is -4. So your C value is going to shift your graph left 4. Okay, so X plus 4, remember, shifts to the left. And then your -9 for your D value or for your K value is going to shift it down 9. So your transformations are shift left 4 and shift down 9. Now, we could have gotten that from up here because your A value, like I said, in front of your x squared term up here, your A value is still going to be the same A value as you would have in your vertex form. So it's still going to tell you if you stretch or compress. Now, what we don't know from the standard form, just looking at it, is what our H and our K are, or what our C and our D are. But once you have the vertex, once you know that the vertex is at -4, -9, okay, we can think about that from the origin. We shift to the left 4 and down 9 to get that vertex. So you can base your left and right shift and your up and down shift based on where your new vertex is. Okay, let's do one where we start in vertex form and then we're going to convert it back to standard form. So let's look at, we'll just look at example 2. So we're going to start down here in vertex form. We're going to get all of our attributes that we know, and then we're going to change it back into standard form, and we're going to see that the attributes are the same, even though we have to use different formulas. So in this first example, my A value is -2, my H value is -4, my K value is 6. Okay, my vertex is H comma K or C comma D. So my vertex is going to be at -4 comma 6, and I'm going to have a maximum because I have a negative A. Okay, my axis of symmetry is at x equals at H, x equals -4. Y-intercept is at 0 comma f of 0, or plug in 0. So -2 times 0 plus 4 squared plus 6. So I have -2 times 16. Oops, I wrote plus 16 instead of plus 6. There we go. Plus 6, which is -32 plus 6, or -26. So I have a y-intercept at 0 comma -26. Okay, my transformations, I'm going to have a vertical reflection because that's negative, or you could say reflection across x-axis. Okay, my A value is a -2, so the 2 is greater than 1, which is going to cause it to have a vertical stretch. It's going to become steeper. H equals -4, or x plus 4 within my function, is going to be shift left 4. And then my K value of 6 is going to be shift up 6. Now, to change from vertex form to standard form, I'm going to expand out my x plus 4 times x plus 4. Then I still have a plus 6. So we're going to distribute x plus 4 times x plus 4. Okay, once you do that, you get x squared plus 8x plus 16. I still have a -2 on the outside and a plus 6. So now I'm going to distribute my -2. -2x squared minus 16x minus 32 plus 6. I can combine together my 32 plus 6, and I get y equals -2x squared minus 16x minus 26. So this right here is going to be my standard form. -2x squared minus 16x, or plus a -16x, plus -26, or minus 26. So I have an a value of -2, b is -16, c is -26. Okay, my vertex, remember the x coordinate is -b over 2a. So -b is 16 over 2 times -2. So 16 divided by -4 is -4. Okay, so I have an x coordinate of -4. Then I'm plugging that into my x's up here. So I have -2 times -4 squared minus 16 times -4 minus 26. Okay, if I were to work all of that out, I would get a y coordinate of 6. So you could type that into your calculator exactly like it's written. It's going to give you the y coordinate of your vertex. Once again, I'm going to have a maximum because I have a negative a value still. Remember I said that a value is the same whether we're in standard form or vertex form. Axis of symmetry is that x equals my x coordinate of the vertex, x equals -4, or x equals -b over 2a, which we said is -4. And then your y-intercept is really easy to spot. It's just your c value, 0, -26.